determine the remainder when it's divided by each of those binomials. So again, we could do this either with synthetic division or with the remainder theorem. We'll do the first one with both, and you can decide which one you think is better. So if I was doing synthetic division, I would set this up as 2, -5, -5, 5, 3. Dividing by x minus 3, I put a positive 3 out there. And I have to go through the whole synthetic division to find out that the remainder is 0. How long did that take? Not very long. I could also figure that out using the remainder theorem. The remainder theorem says if this is my polynomial, I'm going to name it p of x equals that whole thing, then I have to plug in 3. So that would be 2 times 3 to the 4 minus 5 times 3 cubed minus 5 times 3 squared plus 5 times 3 plus 3. It almost took just as long to write out plugging in the 3 than the whole synthetic division took. And in this case, I'd have 2 times 81 minus 5 times 27 minus 5 times 9 plus 15 plus 3. So we've got 162 minus 135 minus 45 plus 15 plus 3. It's equal to 0. I hope you see in this case that the synthetic division was actually quite a bit nicer. You didn't have, right? What's in synthetic division when we did this? What was our biggest number we had to deal with? 6. Ooh, stretch a little bit. 6 is pretty big. And what was probably our hardest math? I don't know, either maybe minus 5 plus 6. That's, yeah, it's got negatives in there. Again, the math was not very hard with the synthetic division. Plus, the synthetic division not only tells us the remainder, it tells us important information as well. It tells us that once you divide by x minus 3, you're going to get 2x cubed plus x squared minus 2x minus 1 is the answer. So you can already write your division statement. So the synthetic division tells us a little bit more. Where does the remainder theorem work nice? When your numbers are small, like 1. Even 2, I might say, I'd probably use synthetic division with a 2. But if it's a 1, you can do mental math by plugging a 1 in here really quick. And then the remainder theorem might be nicer. We're also going to solve some questions where there's variables in the coefficients, and then the remainder theorem is quite a bit nicer. So if I was looking at this second one and I wanted to find the remainder, I could either plug in -2 and just looking at that, thinking about the numbers that I would get, or I could use my synthetic division with a -2 out front. And in this case, whoops, got a little ahead of myself. Bring the 2 down, multiply. Here, the synthetic division had some bigger numbers. Did I make a mistake somewhere? Be a positive. Which one? -2. Yes, positive 42. Thank you. And that makes just the end 45. There it is. So we had a little bit bigger numbers in here. Again, you can still make easy mistakes with negatives and positives with synthetic division as well. But I think the synthetic division is still the quickest. The nice thing about the first one is we can tell that x minus 3 is a factor. What we found out with the second one is that x plus 2 is not a factor because we got a remainder that wasn't equal to 0. So questions you can do are 4a, 6a, 7, that looks like a 9, and 8. And we'll do one more example, and then I'll let you work on these.